Okay, students. So today we will revise chemistry. Okay, but try this question, everybody now. Yes, I'll post question to each of you. Meanwhile, everybody can try. Okay. Yes, Jerome, can you, go through the question and answer? Yes, Jerome, unmute yourself first. Yeah, go through it. 100 grams of aqueous solution contains 10 grams of glucose. Which is a solute, which is a solvent? Tell me, Jerome.
Sir, solute will be glucose, sir.
Mm-hmm. Okay.
And
Ranika, can you tell me?
Sir, solute is glucose and the solvent is water, sir.
Evelyn, can you tell me? No?
Sir, the solute is glucose, sir,
And solvent
and
is?
solvent is water.
Yes. Jerome, can you tell me why you told that answer?
sir, because like the aqueous solution is water, so it is so glucose is dissolved for 10 grams, sir. So water will be 100 grams, so
Water is not 100 grams. Water would be?
90 grams.
Correct. Correct. Very good. Very good. Yes, Ranika, what was the reason for you to say glucose and water?
Sir, because the solvent, the quantity is more, sir.
Very good. Very good. Very good. Okay. Fine, guys. Correct. Yes, ma, less quantity is solute and more quantity is solvent. That's all. All right. So that's why it's glucose and water. Very good. Yes, Gyalson, can you unmute me?
Yes, sir.
Yeah. Ratio of number of moles of solute to the total number of moles of solute plus solvent is called? Yes, Gyalson, can you answer that?
Can you hear me, sir?
Yeah, now I can hear you. Yes. Yes, Gyalson. Tell the answer, ma. You're not audible. Are you trying to speak? Okay, Enoch, tell me, ma. Enoch, unmute.
Yes, sir. Mole fraction of a solute.
Mole fraction of the solute. That's correct. Right? Ratio of number of moles of solute to the total number of moles of solute in solvent is called mole fraction of solute. Good. That's correct. Very good, Enoch. Okay. Okay, now which of the following represents 1 molar solution? Yes, Evelyn, you can tell.
Sir, 1 mole of solute in 1 liter of solution.
Very good, very good. So that's the fourth option, right? Perfect.
Yes, sir.
Perfect. Okay. 1 mole of solute present in 1 liter of the solution, we call it as 1 molar. Right. Perfect. Yes, Ranika. Units of molarity are?
Sir, it is fourth option. Sir.
Molarity, ma.
Molarity. Oh, sir, second option. Sir.
Yes. What is fourth option? What is moles per kg?
It's molality. Sir.
Yes. So what is asked is molarity. Therefore, second option is correct. Okay. Yes, Jerome, you can answer this one.
Yeah.
It's only input, you can go on mute, ma. Yeah, come on, Jerome, try this one. Molarity of a solution increases with temperature, decreases with temperature, may increase or decrease with temperature, independent of temperature.
Sir, independent of temperature.
No. Right? Yes, Zain, can you try this? Unmute, ma.
May increase or decrease.
No. Okay, ma. Yes, Enoch.
It increases.
What? Molarity increases, huh? With increase in temperature. Okay. Evelyn?
Sir, it decreases with increase of temperature, sir.
Yes. And what is the reason for that, Evelyn?
Sir, because if you increase the temperature, the volume increases, and if volume increases, molarity decreases since they have an inverse relation.
Yes, perfect, right? Molarity is equal to number of moles per unit volume, right? Or per volume of the solution liters, correct? Number of moles is not going to change if you change the temperature, correct? So numerator remains same. But volume of the solution, as Evelyn pointed out, if you raise the temperature, volume will increase. Hence, molarity will decrease. Okay, very important, students. So molarity is dependent on temperature. Okay. Important question for a competitive exam. Okay. Yes, Ranika, you can tell this. The number of gram moles of the solute present per liter of the solution is called. Yes, Ranika.
Sir, is it normality, sir?
Yes, Evelyn.
Sir, I'm just confused with gram moles, sir.
Okay. Gram moles is same as moles. That's all. Okay.
And then it is molarity, sir.
Molarity only. Okay. Okay. Yes, Jerome. If I have to decrease the molarity to half, what should I do? Weight of the solute can be doubled, or volume of the solvent has to be doubled, or weight of the solvent has to be doubled, or volume of the solution has to be doubled. Yes, Jerome?
Sir, volume of the solvent to be double, sir.
Seema, you have to understand whenever I'm using molarity, right? Molarity is number of moles per volume of the solution, correct?
So weight of the solvent to be double.
Nothing. Volume of the solution is to be doubled. That's all. See, we just saw, right? In the previous case, if temperature is increased, volume increases, therefore molarity decreases, correct? So if you increase the volume, molarity will decrease, correct? Jerome, are you, when you say halving the molarity, are you decreasing the molarity or increasing the molarity?
Decreasing molarity, sir.
Right. So that means you have to increase the denominator. What is in the denominator of the formula?
Volume of the solution.
That has to be increased, right? If you have to halve it, volume should become double. If you have to make it 1/4, volume should become 4 times. Clear or not?
Yes, sir.
Yeah. So all the second option, third option, all don't come into picture when you're talking about molarity. Clear, Jerome?
Yes, sir.
Okay. Yes, Enoch, unmute yourself now.
Yes.
Yeah, come on, tell me, my Enoch.
Same.
Yeah, Enoch, come on.
1 by 2, 0.57.
Can you explain?
100 millimoles. So it will be on top. So molarity is moles of the solute by volume of the solution.
In liters.
So 100, yes, sir. So it will be 100 into 10 to the power 6 because milli and 200
Not 10 power
milliliters.
6, 10 power minus 3.
Sorry, 10 power minus 3. And at the bottom will be 200 into milli, no? 200 into 10 to the power minus 3. Sir.
10 power minus 3. Or you can say, you can multiply 1000 in the numerator. Yes, that's correct. Yeah. Right. So answer will be 0.5 molar. Perfect. Very good, Enoch. I hope everybody is clear, guys. We'll move on to the next one. So millimoles means 10 power minus 3. Right? Yes, Levin. Okay, next question. Yes, Ranika, can you unmute? Yes. Can you try answering this question? 0.5 moles of a solute is present in 500 ml of the solution. Then what is its molarity?
1 mole, sir.
1 mole. Very good. Can you tell me how, Ranika?
Sir, we have to convert 500 ml into liters, so it would be 0.5 liters, sir. So
Yes.
the number of moles would be on the numerator and 0.5 would be in the denominator. It would be 1 mole, sir.
Very good. Very good. Very good. Right. So it's 1 mole. 1 molar. Very good. That's all. Excellent. Yes, Evelyn, can you unmute?
Yes, sir.
The number of moles of the solute present in 10 ml of the decimolar solution.
Sir, 10 power minus 3, sir.
10 power minus 3. Perfect. Perfect. What is decimolar, Evelyn?
Sir, 1 by 10 molar.
1 by 10 molar. Very good. Very good. Decimolar is 1 by 10 molar or 0.1. So that is the number of moles. I mean, that is the molarity, right? That's on the left hand side. Number of moles we don't know. Let's say it's n divided by 10 ml. See, a liter it should be, right? I mean, per liter, right? So what you should convert to liters. So 10 in the denominator and numerator you can make it 1000. So overall you will get 10 power minus 3. Perfect. Evelyn. So number of moles of solute is nothing but molarity multiplied by the volume in liters. So molarity is 0.1 into volume is 10 ml. So that's nothing but 10 divided by 1000. So 1 10 gets cancelled. This 10 power minus 2. This 1 by 10 is 10 power minus 1. So you get 10 power minus 3. Very good. Okay, now next question now. Yes, Jerome, can you try this? Come on, Jerome, unmute. So first unmute, Jerome.
Yes, sir.
Yeah. Write the formula for molarity. What is molarity equal to?
Number of moles of solid divided by volume of the solution.
Correct. What is given here? What is this 0.5 m means what?
Molarity, sir.
Molarity is given. What is 0.5 decimeter cube?
Volume of the solution.
Correct. Decimeter cube means what?
Into 1000, sir.
Nothing. In decimeter cube itself means
cm.
liters. Okay. Decimeter cube is equal to liter. Clear?
Yes, sir.
So 0.5 decimeter cube will be how many liters? What do they think? 0.5 decimeter cube is 0.5 liter. 1 decimeter cube is what, Jero? Come on, repeat with me 5 times. 1 decimeter cube equal to 1 liter. Tell it 5 times.
1 decimeter cube is equal to 1 liter.
Go ahead.
1 decimeter cube is equal to 1 liter. 1 decimeter cube is equal to 1 liter. 1 decimeter cube is equal to 1 liter.
Yes. Now tell me, Jero. Yeah.
So 0.5 decimeter cube is equal to 0.5 liters, sir.
Correct. Right. So volume is given, molarity is given. All that you have to find is the number of moles. Can you find it now? Substitute in the formula and tell me.
.25, sir.
Very good. That's all. Right? 0.25 is correct. Very good. Okay. Levin, are you ready now?
Yes, sir.
Okay. So let's move on to the next. You try this question. Tell me the answer for this question, Levin. What is the molarity of the solution of sodium hydroxide? 4 gram is taken and it's present in 100 ml of the solution. Ready, Levin? Yes, Levin, what happened? Unmute. What happened?
So I'm getting different answers.
Okay. Okay, Enoch, try this. Tell me.
That is number of moles by volume. So volume is 100 ml. So that is 100 into 10 to the power 3. 4 gram number of moles of is any of the 4.
How do you find number of moles? What is number of moles? Tell me, Enoch.
Gram by molar mass.
What gram by? Given mass by molar. Given mass by
given
molar.
mass by.
Very good. Very good. Then everything you know. Come on, tell me. Given mass is what?
35.
35. Where is 35 here?
Anyways, sir.
So we have to given weight by molecular weight into 1000 by volume, right?
What, Levin?
So for molarity, we have to find number of moles. So
number of moles we have to find. So how do you find number of moles, Levin?
So given weight by molecular weight.
So all of you are correct. What do you do? Given weight, what is given weight, Levin?
So 4 by 40.
4 by 40.
Okay. What, Enoch? 40 or 35?
40, sir.
How did you get 35? Okay. Fine, 40.
40 by 4, you get 10. So 10 by 100 into 10 to the power 3. So you get
Okay, tell me if the answer is not there, I'll add the option.
0. Sorry, sir, 0.1.
0.1, huh? Okay. What, Levin? So Enoch is getting one of the options, one of the answers which are given in the options. And you are getting something else, right, Levin? Tell me your option, we will add it. Okay. Come on, guys, very simple. What is the answer, Anika?
Sir, it is 1 mole.
1 molar, ma. That's all. Not 1 mole, 1 molar.
1 molar.
Correct. So that's all, right? So 2 ways of doing it. 4 grams is present in 100 ml. So how much will be present in 1000 ml? 40 gram. 40 gram is 1 mole. So 1 mole is present in 1 liter. Therefore, the molarity is 1 molar. That's all, right? Or even if you use the formula, molarity is equal to number of moles by volume. Number of moles is 4 by 40. Volume is what? 100 ml, right? So you have to multiply by 1000, right? Your numerator. So this is 10. So 1000 cancel, 1 molar. Okay. What? Levin? Are you there? Okay, just Enoch, did you get it now?
Yes, sir.
Okay. Fine. My next question. Yeah, Evelyn get done completed now. Two grams of sodium hydroxide present in 1 liter. So what should be the molarity? No calci.
Sir, 0.05, sir.
Correct, right? So if it is 40 grams, it is 1 molar. If it is 4 grams, it is 0.1 molar. Half of that is 0.05. Okay, very good. Very good. Next. Jerome, come on. .9 grams of sulfuric acid in 500 ml. What is the molarity? Why so much time? Yes, Jerome, what is the answer?
So 0.1, sir.
0.1, right? Evelyn, what is the answer?
0.1 molar.
Correct, right? Okay. Fine, guys. So obviously, what did you do, Jerome?
So first we calculated number of moles of sulfuric acid. So 4.9 divided by 98, sir.
Yeah.
So then we get 0.05. We use molarity formula, which is number of moles of solid divided by total volume of the solution in kg. So
kg,
liter, sir. So then it will be 0.05 divided by 500 into 1000, since 500 is in milliliters.
Yes,
so
1000 will be in the numerator. Correct, right. So now, of course, I'm glad that you guys are doing it, but I want you to answer within a few seconds. Okay, it's possible to do that. So I would also recommend you, right? Nothing stopping you from doing it this way. First thing is you should not use calculator, right? Because otherwise you'll not know the estimate of time you're taking, right? And you don't have that privilege in your competitive exam, right? So you must avoid using calculators, right? Questions will be given in such a way that they'll cancel easily, right? Okay. And one more method of approach you must use. I want you to use this, right? Slowly. See here, if I am given this question, how would I solve it? Let me just show you. See here, 4.9 gram of sulfuric acid is present in what mark? Is present in 500 ml. So how much will be present in 1 liter? Double of it, right? 9.8 gram. If 98 gram is there in 1 liter, it is 1 molar. If 9.8 gram is there, means it is 1/10 of it, which is 0.1 molar. This will just take me a few seconds to get the answer. Now, are you following this, Evelyn? What I just shared?
Yes, sir.
Yeah. So I recommend, you also need to start using this. Ranika,
Yes, sir.
did you understand the approach?
Yes, sir.
Okay. Okay. What about Jerome?
Sir, can you explain it once again, sir?
Sure. See here. Same, suppose I have 1 dairy milk chocolate, it costs 50 rupees. If I have 2 dairy milk chocolates, how much does it cost?
100 rupees, sir.
That's all, right? So now listen carefully, Jerome. In 500 ml, how many grams is there, Jerome?
4.9 grams, sir.
So suppose if I double everything, like 1 liter volume, same concentration should be there, means how much sulfuric acid should be there?
9.8 grams.
Double, right? Double.
Yes.
So is this clear to you, Jerome?
Yes, sir.
Yeah. And you know the molecular mass of sulfuric acid is 98, correct?
Yes, sir.
So if 98 grams is there in 1 liter, it is called 1 molar, correct? Because 1 mole in 1 liter, correct or not?
Yes, sir.
Did you see one of the questions where we asked what is molarity? 1 mole of the solute present in 1 liter of the solution. Understood or not?
Yes, sir. Understood.
So 98 grams is present in 1 liter, correct? Then it is 1 molar.
Yes, sir.
But now how much is present?
9.8 grams.
Yeah. So it will be how much molar?
0.1 molar.
0.1, right? Because divided by 10. So did you understand this, Jero?
Yes, sir.
Yeah. So slightly, it will be faster. Okay. Okay, guys. Good. No problem, right? We'll move on. Okay, next. Enoch, unmute now.
It didn't load completely.
Yes, Enoch.
No, it didn't load completely.
Oh, yeah. Now is it okay?
Yes, sir.
Barium hydroxide molecular mass is given. Sorry.
Will it be 0.5 moles?
No.
It will be third. Sorry.
Third option. Very good.
Third option.
Right? Because milligram, right?
Yes, sir. Yes, sir.
Yeah, 171.4 milligram is there. 171 divided by 171 will give you number of moles, right? So it's 1 millimole. 1 millimole is present in 200 ml. So in 1000 ml, how many millimoles will be there? 5 millimoles. Therefore, the molarity is 5 millimolar. So answer is 5 into 10 power minus 3. Good. Okay, ma? Good. Yes, Fuzail, can you unmute me?
Yes, sir.
Yeah. Tell me this one. Number of moles of glucose present in 500 ml of 2 molar solution. So molarity is given, volume is given, you are asked to find number of moles. Tell me the formula for Fuzail first.
So number of moles will be weight by molecular mass. So
That's fine, but we don't, we are not given the weight, right? So that's not important.
yes, sir.
Tell me the formula for molarity.
So number of moles of the solute by volume of the solution.
Yes. So volume of the solution is given.
Yes, sir.
What is it?
So 0.5 liters.
Yeah, 0.5 liter. Correct. Is molarity given?
No. Yes, sir. 2 molar.
What is it?
2 molar.
Yeah. So molarity is given, volume is given. Can you not find the number of moles? So what is the number of moles?
Yes, sir.
That?
1, sir.
Yeah. Is it clear now, Vijay?
Yes, sir.
That's all. So number of moles is nothing but volume multiplied by molarity. That's it. So you just have to multiply these two. So 500 ml into 2. 500 ml is 0.5. 0.5 into 2 is 1. That's
Sure.
Good. So number of moles is volume into molarity. That's it. So 1 is the answer. Good. Okay, my next. Yeah, Levin, you can unmute now. Did you drop off, Levin?
Sir?
Did you drop off in between?
Yes, sir. I don't know why my laptop is not working.
Okay. Just tell me the answer for this, Levin.
Yes, sir. 1. Sir, can you hear me?
No, now I can hear you.
Oh, yes, sir. Third option.
Yes, right. So volume is what? Volume is 250 ml and molarity is given. Volume multiplied by molarity will give you number of.
Yes, sir.
So that's volume is in liters. If you say it's 1/4. So 1/4 into 0.01. So just multiply 10 and divide 10. So you'll get 10/4 is 2.5. The divided 10 goes as 10 power minus 3.
Yes.
So you get the third option, right? Perfect. You just need to multiply these two, right? Good. Next. Yes, Evelyn? Can you unmute Evelyn? Please unmute.
Yes, sir.
Yeah. Just solve this and tell me. Yes, Evelyn?
Sir, 100 ml, sir.
100 ml. Okay. So what did you do? Molarity is equal to number of moles by volume, right? We don't know what is volume, so we take volume to the side. So number of moles divided by molarity, right? So number of moles is nothing but what given weight by molecular mass. So 2.12 is what is given. What is the molecular mass of sodium carbonate?
Sir, sodium carbonate is 106, sir.
Exactly, right? 106. Divided by molarity. How much is the molarity?
Oh, sir, I took it as hydrous, sir. I added 18, so it's not 100 ml, sir.
Okay. So you got the idea?
Yes, sir.
Is it not 100 ml? Okay, let's see. So if I write as 21.2 by 2, so it will be what, 10.6, right?
Yes, sir.
Correct. So you will get, I think you will get 100 ml, right? 1 by 10th of a liter, which is 100 ml, right?
Oh.
What happened, Evelyn?
Sir, no, sir. I did not take the molecular weight as 106. I added 18. I got 124.
Okay.
I took it as hydrous instead of anhydrous.
Okay. So your point is always see, right? 106 into 2 is 212, right?
Yes, sir.
So always they will give it in such a way that you can cancel it easily in competition.
Yes, sir.
Okay, good. Yeah, 100 ml is correct. I hope everybody followed. Okay, next question. Yes. Enoch, you ready?
Yes.
Yes. Okay. I hope you have noted down everybody. Come on.
Sir, can you show the previous slide? 1 minute.
Yeah, sure.
Yes, sir. Thank you.
Yeah. Okay. Yes, Enoch, this for you. How much volume of water should I add to already existing 100 ml of 0.5 molar urea so that I make it decimolar?
Sir, decimolar is 1/10 of a molar. No?
Yes, perfect. Yeah. Okay, it's open for everybody. Anybody gets the answer, just let me know.
Sir, I don't know how to approach it, but it's 400 ml.
How are you thinking 400? Can you tell me?
So 100 ml. So it's plus 400, you get 500 ml.
Yes.
And when you multiply that, get 7 ml, and molar mass of urea is 60. Huh?
Correct. Very good. But
so you have to
go into
500
molar mass. Tell me, Enoch.
Oh, then you have to do 500 ml is the correct answer, sir. So 60 by 600. And you get yes, sir, 60 by 600, and you get 0.1. Is that right?
No. 60 by 600 means, see here, 60 is urea molecular mass, correct?
Yes, sir.
Suppose if you take 6 grams present in 60, 6 divided by 60 will be 1 by 10. If that is present in 1 liter, then it becomes 0.1 molar.
Oh,
okay.
So, sorry, it's in ml.
Yeah. So anyways, okay. Anybody else with the answer, ma? Yes, Evelyn, are you ready with the answer?
No, sir.
Okay. What about Ranika?
No, sir.
Okay. So I'll tell you two approaches, right? One a long approach, another one a short approach. Okay. Fine. See here. Now, initially, let's say molarity is given. Molarity is equal to number of moles by volume. Correct. So here molarity is given, which is 0.5 initially. Volume is 100 ml. So which means I know the molarity, right? Sorry, I know the number of moles. What is the number of moles? Is it clear to you? I got the number of moles. Now, new molarity, number of moles, that means some grams of the solute, that won't change, right? That's same, divided by the new volume, correct? So if you see, the new molarity that I'm interested in is what? 0.1. Right? Number of moles is going to remain same, 0.05. The new volume I want. So the new volume will be 0.05 is divided by 0.1, which is 0.5 liters. Or in other words, 500 ml. So the new volume will be 500 ml. But already I had 100 ml, right? So how much I should add? Already I had 100 ml. So how much I should add?
400.
400. Therefore, 400 is correct. Okay. So this is a longer process. Now, what is shorter process? Very simple. M1 into V1 equals M2 into V2. That's it. M1 V1 equals M2 V2 is the shortest possible way you can get the answer. That's okay. So M1 into V1, so that's 0.5 into 100 ml is equal to M2 is 0.1 into V2. So V2 becomes 500 ml. So I have to add 400 ml. That's clear. But idea here is the number of moles is same. That's why. So there is no need for molecular mass in this case. So instead of urea, had it been glucose, answer will be
Sir,
same. Yeah.
can you explain how it is 400 ml, sir?
Evelyn, the final volume of the solution must be 500 ml, right?
Yes, sir.
Correct, for it to become decimolar. So what is the question asked? The volume of water that needs to be added to the 100 ml is asked. So already 100 ml is there. You're going to dilute it more, right?
Yes, sir.
So the total becomes how much?
500.
Yeah. So how much more are you adding?
400.
That's all. So is it clear, Evelyn? Yes. So I hope all of you are clear with this. Very good. If taken down, we can move on to the next. Shall we move to the next? Are you done? Okay. Okay, ma, come on now. Who will answer this? Levin, are you there?
Yes, sir.
Yeah. Can you tell me one? A very similar question. The volume of water that needs to be added to convert an already existing 10 ml of decamolar HCl solution to decimolar solution. What is decamolar, Levin?
Sir, I know decimolar is 1/10.
Yeah, deci is 1/10. What is deca?
10.
10. Yes. Decamolar means 10 molar. Decimolar is 1 by 10 molar. Good.
Just a minute.
Sure.
So can you hear me?
Yeah, I can hear you now.
Sir, is it 1000 ml?
Okay, so 1000 ml is an expected wrong answer. If you do the M1 V1 equal to M2 V2, you'll get 1000, no doubt about it. But the question is how much should be added to convert 10 ml? So you will be adding 990 ml so that in order to make it 1000. Levin, like the previous sum, right? Your answer was 500 ml.
Yes.
But then how much did you add? Did you have to add to 100 ml? To make it 500, you have to add 400 ml. So like that, your answer is 1000 ml. 1000 ml is what will make it smaller. But to the existing 10 ml, how much should you add? 990, so that it becomes 1000. Are you getting it, Levin?
Oh, okay. Yes, sir.
Yeah. So this is where you stopped and you took 1000 ml, right? Yeah, but this is what 990 is what you need to add so that it becomes 1000. So are you clear, guys?
Yes.
Good. Okay, we'll move on now. Okay, Ranika, you can try this. Sulfuric acid is labeled 0.98%. What is the meaning of that, Ranika?
Weight by volume is 0.98%.
What is the meaning of that?
The
How much of sulfuric
0.98
acid?
grams.
0.98
Grams.
of sulfuric acid is present in?
Is present in 1 liter solution.
Yes, Evelyn, can you tell me?
Sir, it means 0.98 grams of sulfuric acid is present in 100 ml of solution.
Yes, percentage itself means something to do with 100, Ranika. Yeah.
Yes.
Yeah, so if you miss that, then all calculations will go wrong, right? So 0.98 gram of sulfuric acid is present in 100 ml of the solution. That's all. So you got the volume, you got the weight, you can find molarity. Very simple question. Come on, do it, Ranika, tell me.
So is it 0.2 molars?
No. Very, very simple question, right? 0.98 gram in 100 ml. So in 1000 ml, how much it will be? 9.8 gram. 9.8 gram means 98 gram in 1 liter is 1 mole. So 1 molar. So 9.8 will be 0.1 molar. So answer is 0.1 molar. Even if you have to do it by the formula, molarity is equal to number of moles by volume. Number of moles is weight by given mass, molecular mass. Weight is 0.98 gram. Divided by molecular mass is 98. Volume is 100 ml. 100 ml means you have to multiply by 1000. So 0.98 by 98 is 100. 100 and 1000 10 times, right? So 10 by 100 is 1 by 10. That's all, Ranika. How did you get 0.2? Okay. Fine, guys. It's very simple. Next question. Yes. Jerome, try this one. What are the units of molality?
Moles per kg, sir.
Moles per kg. Very good. Right. Okay, ma Enoch. In the reaction, H2CO3 plus NaOH gives sodium bicarbonate and water. The equal weight of carbonic acid is. Yes, Enoch. What is the molecular weight of carbonic acid? What is carbonic acid in this equation, this reaction?
H2CO3.
Correct. That is carbonic acid. Correct.
So,
what is the molecular mass of carbonic acid? Huh? Okay. Evelyn?
Sir, 31, sir.
Okay, Evelyn. So could you tell me what made you tell the answer?
Sir, in the reaction, 1 mole of carbonic acid is reacting, so its weight is 62 grams, and the basicity of carbonic acid is 2, sir. So we so to find equivalent weight, we do molar mass by basicity, so 62 by 2, which is 31.
Okay. Tanika, do you agree with the answer?
Sir, could you just explain it?
Okay, you do not know. What about Jerome?
Yes, sir.
You agree with the answer. What is the formula for equivalent weight of an acid? Molecular mass by basicity, right? Okay. Yes, Levin?
Sir, I couldn't hear you, sir. I left the meeting. Can you repeat this?
Okay. So the question is, what is the equivalent weight of carbonic acid? And Evelyn said it's molecular mass by basicity, and basicity for carbonic acid we know is 2. So it is 62 by 2, 31. Do you agree with it? Okay. What about Fusail?
Yes, sir.
So what is the formula for equivalent mass of an acid?
So molecular mass by basicity.
What is basicity?
So 2, sir.
No, what is basicity in general?
So the number of hydrogen atoms that are released.
Yes, correct. So good. Okay. So she says 62 by 231. Is it correct?
Yes, sir.
Yes, okay. Yes, Evelyn. So, so it's an expected wrong answer, Evelyn. Okay. So why is it expected? Because you're perfect in using the formula, right? Molecular mass by basicity. But one thing what you missed. So can you tell me what you might have missed? Evelyn, are you able to guess what you missed?
1 minute, sir.
Yeah.
I'm not sure, sir.
Okay, just observe carefully, Evelyn. See here, no doubt the basicity of carbonic acid is 2. That means the number of possible replaceable hydrogen H plus ions are 2, right? But in this particular reaction, not all the 2 hydrogen atoms are getting replaced. See here, one hydrogen is replaced by sodium. So you're getting sodium bicarbonate, right?
Yes, sir.
So are both the hydrogens replaced or only one is replaced, Evelyn, in this equation?
Only one, sir.
So in this reaction, equivalent weight is not, 62 by 2, but it is 62 by
1.
1 because only one of the two hydrogen atoms are getting replaced. Therefore, it is 62. Are you clear now, Evelyn?
Yes, sir.
Yeah. So whenever they give you a reaction, if reaction is not given, simply if I give you carbonic acid, then your answer is correct. But in this particular reaction, we have stopped at the stage where only sodium bicarbonate is found. Probably further reaction with sodium hydroxide is allowed. Then you will get sodium carbonate. Finally, the basicity will become 2 if that is allowed, right? But you're not letting the reaction happen, right? So you're just stopping at this point. So in this reaction, the equivalent weight is 62 divided by 1 only. Okay. So good. So it's clear, right? So basicity is only 1 now because of this. Did you get this? Only 1 H plus is being removed. Okay. Next question. Yes. Yes, Evelyn, you can answer this question now.
Sir, 98, sir.
98. Very good. Very good. Normal equivalent mass is molecular mass by basicity. And basicity, the moment you see sulfuric acid, what comes to your mind? Basicity.
2, sir.
2. But in this reaction, it is not 2 because only one
Only
hydrogen
one
is replaced.
hydrogen is replaced.
Exactly. Therefore, it is 1. Hence, the answer is 98 and not 49. 49 would be an expected wrong answer. Very good, Evelyn. Excellent. Okay. So now let's move to the next one, students. I hope you are taking it down. Okay, now, Ranika, can you answer this next one? Yes, Ranika. Can you unmute now?
Yes.
Yeah. How do you calculate the equal weight of a salt? Yes, Enoch, tell me, ma. How do you calculate the equal weight of a salt?
Sir, I don't have some.
You don't know. Okay, Jerome? Unmute, Jerome.
Also not sure, sir.
Not sure. Yes, Evelyn?
Sir, M by 2, sir.
M by 2, right? How did you get it as 2, Evelyn?
Sir, because we in cases of salt, we have to see the charge on the cation or the anion, sir.
Very good, very good. So charge
So
on the
it is
cation Ca is what?
molecular Ca2 plus or CO3 2 minus. So it is molecular weight by 2, sir.
Very good, very good. Excellent, excellent, right? So molecular mass divided by charge on the cation, right? So your calcium carbonate is nothing but Ca2 plus, right? Or in other words, it comes from carbonic acid, H2CO3, which is a dibasic acid, right? Okay, so answer is M by 2. Very good. So now, yes, Enoch, did you get it?
Yes, sir.
Molecular mass divided by charge on calcium. Calcium ion, how much is the charge?
Plus.
2 plus, right? 2. So equivalent weight of the salt is molecular weight divided by charge on cation or anion. Very good. Okay. Yes, Fuzail, unmute.
Yes, sir.
Yeah, next question. Okay, molecular weight of potassium permanganate, KMnO4 is M, let's say. In the reaction, KMnO4 is getting reduced to K2MnO4. What will be the equivalent weight of KMnO4?
So not sure.
Not sure, right? Okay. So I'll tell you how to do this to students. Please make a note. So you see what is the charge of the manganese ion here? You know how to find charge of the manganese ion, right? So when I say KMnO4, observe this carefully. What is the charge on potassium? It is always +1. What is the charge on manganese? You don't know. Let's say it is X. What is the charge on oxygen? -2, correct? So it is 4 atoms are 4 into -2. So 1 plus X. I think you've done this in redox reactions, right? 4 into 2, 8. So X minus 7. And overall this is neutral, therefore equated to 0. So can you tell me the charge on manganese? +7, correct? Now, unmute now, tell me for K2MnO4, MnO4.
So potassium will always be 1%.
Yes, yes.
So Mn will decrease by 2.
Sorry?
The charge of Mn will decrease by 2, so it will become 5 plus 5.
3.5. No, do the
No,
calculation.
plus 5, plus 5, sir.
Huh?
Plus 5. No.
Wait.
Plus 6, sir.
Okay. So 2 into 1
plus 6
plus X minus 8 equal to 0. So X minus 6 is 0. So X is +6, correct. So when KMnO4 converts to K2MnO4, what happens to the charge? What happens to the oxidation state of manganese, Enoch?
It
decreases by?
Decreases by 1.
By 1, right? So that number is what you need to divide. So your equivalent weight will be your molecular mass divided by that number. What is that number? The number of electrons or number of electrons lost or gained. Or the change in oxidation state. How much is the change in oxidation state?
+1.
1. Therefore, what will be the equivalent mass?
1.
Molecular mass. Clear, Enoch?
Yes, sir.
Yes.
Excuse me, sir.
Yes, Evelyn?
Sir, in the reaction, if we also consider, like here we have KMnO4, but then it is reduced to K2MnO4. So can't we take it as 1, sir? I mean, the potassium is getting reduced by 1, right?
Potassium is neither oxidized nor reduced. Potassium charge will become +1 only. If you write
Sir,
the balance,
why are we considering only manganese, sir?
here potassium permanganate, if you see KMnO4, right, Evelyn?
Yes, sir.
Oxygen's oxidation state is not changing. It is -2 only.
Yes, sir.
Potassium's oxidation state is also not changing. It is +1.
Yes, sir.
So it is only changing for manganese. That's why we are considering manganese.
Okay, sir.
Is it clear, Evelyn?
Yes, sir.
Yeah.
But how do we know what is changing and what is not changing?
See here, it is quite easy to know, right? The point is it's an alkali metal. Potassium is an alkali metal. Alkali metals don't exhibit multiple oxidation states, right? Sodium, potassium, lithium, sodium, potassium, rubidium, cesium, all these are group 1 elements, correct?
Yes.
Yeah, they all exhibit the oxidation state of +1, correct? Yes, Enoch? And similarly, oxygen, except in peroxide. Peroxide, it gives you -1, right? Oxidation state. But most other compounds, it is -2, correct?
Yes, sir.
Yeah, so those remain fixed. And manganese is D block element, correct?
Yes, sir.
The transition element, it exhibits multiple oxidation states.
Yes.
So hence,
understood, sir. Yes.
yeah, you got it right.
Yes, sir. Yes.
Yeah. All right. Next question to Evelyn. You can try this. SM. M is the molecular weight of ferrous sulfate. It's equal in weight when it reacts according to the equation. So where will be your focus, Evelyn? Which compound?
Sir, ferrous sulfate.
In ferrous sulfate, which is likely to have a change in oxidation state.
Iron, sir.
Correct. So just look at that compound. So ferrous sulfate, what is it changing to?
It is changing to ferric sulfate.
Ferric sulfate. Very good. Very good. So what is the oxidation state of iron?
+3. +3.
Ferrous sulfate, it is +2, right?
Yes, sir.
And
Ferric, it is +3.
Yeah. So ferrous sulfate is changing to ferric sulfate. So +2 is changing to +3. So what is the transfer of, how many electrons are lost?
Only one, sir. It is N.
Exactly. Is it clear now, Evelyn?
Sir, I have a question, sir.
Yeah.
Sir, here even manganese is a D block element, so why are we not considering that, sir?
Here, manganese is getting reduced. See, the question is, they have only asked you the equivalent weight of ferrous sulfate. That's the reason we have not considered
So we should just see the change in oxidation of ferrous sulfate, sir, in
Yes,
this question.
Only that. Only that.
Okay, sir.
As we rightly said, manganese has also undergone change in oxidation state. Here, manganese oxidation state is +7, whereas in manganese sulfate, right, oxidation state of manganese is only +2.
Yes, sir.
All right. So we are not bothered about it because we are only asked to find the equivalent weight of ferrous sulfate. Clear, Evelyn? Okay.
Yes, sir.
So, right. So with that, we will complete this discussion and we'll move on to a new chapter today. Okay. Just go through. Of course, we will have, again, in the next chem class, we'll also have a discussion or revision of the other parts of this chapter, right? Colligative properties, normality, more of molality, mole fraction, right? All this we'll just take it up in the next class. Meanwhile, the next 50 minutes, we will get started with the next chapter.